This talk's going to be slightly different from the previous talks. I guess it will be a little less technical, especially for you who are all very deeply involved with JavaScript. So I have to apologize for maybe it might be a bit more shallow and going to a different direction. I'm going to be talking about making HTML5 games with JavaScript, or TypeScript in our case, and we're building heavily on SVG. So that's Lost in the Garden, which is a 4-person team, and it's 2 artists, 2 programmers, or kind of 2 arts, 2 tech, and that seems to be working quite nice. So all our projects are kind of in the overlap between art and tech. Where we started out roughly 3 years ago was as a video game developer, which we still are. So we did the game's called Lightfield. It's on PlayStation and Xbox, and also Steam. And it's a fancy racing game and so on. So it's a bit different from the average web stuff. We also did VR, also in Unity. So that's C#. It was a demo where you could manipulate everyday objects and do fancy stuff with it. But besides kind of games and VR and their own projects, we're also doing contract work. So part of the company's games, part of the company's contract work. So roughly a year ago, or a year and a half ago, a client came to us and said, well, we need HTML5 games, and you're a game developer, so can you help us out with HTML5 games? I said, well, yes, of course. And the thing is, HTML5 is kind of different technology than what we were used to. So a lot of the time, the good thing was it was a relatively small project, but we had a lot of time to do it because the client said, okay, just be done whenever it's done. So it was very lucky for us that we had a lot of time to develop our own tech, do some research, because JavaScript was quite new to us, all the kind of the JavaScript ecosystem, all the packages and so on, that was very new to us. So a lot of time went into learning these things. So in the end, we did a couple HTML5 games, and here's just a very rough demo. It's a bit smoother if it's not a video. So the constraints that we have was HTML5 has to run on every platform, kind of modern browser-based platform, and also every aspect ratio. So from classical landscape desktop browsers to portrait mode, very tall mobile phones. And the games are quite short. It's roughly 5 minutes. It's we started with 6 different games, targeting different skills and so on. So it's kind of a mix of stuff. If you want to try something out for yourself, here's 2 prototypes that we have brought. The left one is probably the more exciting one. It's kind of a very, very simple memory-ish game where you have to memorize stuff. And the right one is more of an infographic type thing. So these are very quick prototypes that we did for another client, just for demo purposes. And they are built on our pipeline, and I guess it took us 3 days or something like that to build those. So it's once everything is running, the pipeline works quite smoothly for us. Okay, some of you are playing, so it seems to be working.
Now you lost the whole audience.
Yes. Okay, so I'd like to talk a bit about kind of why we went where we went, because there's already JavaScript game engines out there, Phaser and so on. There's a lot of JavaScript games out there. But still, for us, it wasn't really a good fit. So when we started the project, Raimond, our creative director, he came up with these mood boards. So that's not art from him, but it's art that he found that he wanted to drive the project with. And his art style, and also what you can see in the mood boards, is kind of flat colors, illustrative style. He also does a lot of things with font and so on. So kind of the rendering quality was very important for us. And this is one of the reasons why we went with SVG instead of something canvas-based, because we wanted always to have very good, very crisp rendering quality. And this is, I'd say you can get away with rendering to canvas if it's just geometry stuff, but with font rendering, it's very hard because subpixel anti-aliasing and so on. These are the things that you get for free and out of the box if you're using SVG. SVG font, you can use web fonts, so a lot of the things work out of the box in our favor, and this is why we went with SVG. And many years ago, I did a couple experiments with D3, so I was kind of used to, oh, I have an SVG and I can just plug stuff in, I can move stuff around, so it felt okay. As I mentioned, we had these different aspect ratios, so the concept, as you already saw, was we have kind of one large game world and then the camera pans around in it. And the good thing is, it doesn't really matter how your aspect ratios, we always constrain the gameplay to a square, and the square always fits the screen. And if you see more to the sides or more to the top of the bottom, there's nice background stuff that you see, and it just doesn't break or anything. So that also worked quite nicely for us. Yeah, so initially we didn't really want to reinvent the wheel, and I spent a lot of time researching other JavaScript engines. And one of the things that we also missed, so we coming from Unity and C#, is so Unity is a game engine. I don't know how many people of you are familiar with Unity. Yes. A couple of you. So Unity 3D is kind of the right now it's kind of Unity and Unreal Engine. They are kind of the two standard game engines for, at least for independent developers up to a certain size. Call of Duty and GTA are not built with Unity. They have their own tech, but pretty much everybody else who doesn't have millions of development budget, they probably use either Unreal or Unity. So these are the classical game engines. And one of the benefits of those is that you have a very good editor. So it's a lot of big part of games is content, and the way to create content, to manage your content, that's the driving thing. So for us, this is where we came from, kind of very simple tech stack, Unity, C#, a couple libraries, but nothing too fancy. And this is what we're faced with. Not really being familiar with the web, it was mind-blowing, to say the least. It was really, in the beginning, quite tough for us to understand what the different things are, what's the different package managers, kind of what's the stuff everybody used a year ago and nobody's using anymore, and kind of what's the new stuff and why is everybody going to the new stuff. So being new to the field, this was a very, there's quite a big hurdle for us to get into, to making sure that we are on the right technology for whatever we're doing, and making sure kind of we get an overview over all the existing technology to make sure that we choose the right technology. And maybe in the end of the talk, you will all come up to me and say, why didn't you use technology X? And I would really appreciate it if you did that. And probably the question is because we didn't really know that this existed. So if something comes up to your mind, then please tell us. We're always eager to learn. It was quite clear for us that we want to go with TypeScript. That came up pretty early in our research. Personally, I am quite intrigued with JavaScript. So I read the JavaScript good parts a couple years ago. So I kind of like JavaScript, and I also hate JavaScript for all the pros and cons of it. And so TypeScript seemed to be the right thing for us, because we wanted to have type checking, we want to have compile errors, we don't want to have things breaking in production, we want to have linters, we want to have types, we want to have static checking, we want to have diagnostics and so on. So that's because this is where we came from, the C# side, making sure that we don't shoot our own leg in the development and not find out until it's released. So that was very important for us, and TypeScript seems to be the very good thing. And so it's not that we kind of really built a game engine. So the game engine code is very, very thin. It doesn't really do many things, because the games are relatively simple because it's only web, and it's not 5-hour epic something, but 5-minute experiences. So it's the game engine part per se is not that complicated or not that interesting, but the pipeline getting there, this is kind of really where the meat is in this project. To getting all the art into the game, and a lot of went into thinking code versus data, and data not as in REST APIs, but data as in the art that we need for the game, configuration for the game, how fast is a character supposed to be moving. We could all hard code that in the code, or we could kind of try to separate out all those and make sure that we have a way to work with that. So the pipeline that we use as our editor, because that was kind of the main thing that we were missing from many existing HTML5 engines. So we're using pretty much kind of roughly any graphics editor. We started off with Adobe Illustrator, and then we moved on to the Affinity Designer. So it's your standard vector graphics thing. You could even use Inkscape if you really are into that. And it allows us to organize our content, to put all the content in there. So our designers, they work pretty much exclusively in there. They can lay out all the content, do sprites and so on, and it works quite nicely. So this is kind of our main editor where everything, art and content happens. And then we have also a very strict folder structure. Project is structured in a certain way. So, and then we have a compile step where we take all our assets and transform them or compile them into the production thing. And this compilation step and this pre-processing step is very important for us, and this is where a lot of the things happen. So here's just, yeah, that's another thing that we wanted to have, is have everything as much standardized as possible. So when I check out the project on any computer, or a colleague checks out the project, they only have to run npm install and then just gulp watch, gulp serve, and that should be it, hopefully. So that's, if nothing breaks, then this is, and we are sure whenever we're doing a build on any machine, the output is supposedly the same all the time.
NVM to fix your backend?
Sorry?
Are you using NVM to define
NVM? NVM? Probably not. Yeah, and then, I mean, you all know that. So just, and kind of also the browser as a debugger, and it works very nicely, source maps and so on. So it's very convenient for us to work. So that's the pipeline as it is right now. Gulp is our main thing, and Gulp is also what we use to copy stuff, to process images, to do stuff. TS-lint, browser for packaging, then of course TypeScript. In the end, Uglify.js, and then Bundle.js. So that we have one Bundle.js in the end that then contains everything. And this was also a very steep learning curve for us to understand all how bundling works in the browser. So it works now, but I'm not sure if this is the best way to do it. Okay, so this is kind of interesting. So this is what we were faced with, kind of the problem of separating code and data, because many times in an SVG, we use a lot of the IDs. So you define the IDs in your editor, and then you use them in the code to move stuff around, to do things with it. So in the beginning, we had our IDs. It was on Illustrator, which is not as stable as it should be. And then, by hand, we just generated kind of our constants file to make sure that at least we don't have that many magic strings. So just one place where we say, okay, the overview is, the ID of the overview is overview _1_, and the _1_ is something that Illustrator introduced. So if something changes in the SVG during the export step, then at least there's only one place that we have to fix. But still, the thing is with Illustrator, at that point, things can change quite easily. And the bad thing is that you don't really know that things break until they break. So that was quite a big of an issue for us. So the intention is always there's no more magic strings. We're always trying to do as little magic as possible with as much sparkles as possible. So what we then did is that we integrated a step in our build pipeline. So we take the SVG, we transform it in our build pipeline, we go through all of the the IDs, and we generate code out of it. And the code that we generate is this definitions file, or this constants file. So whenever something changes in the SVG, because the designer changes something, introduces new stuff, renames thing, maybe they correct a typo, something like that. It's not that the end project breaks, but since kind of the ID name and the string are the same, if the ID changes in the SVG, it also changes the identifier, which means it introduces a compile error into the project. So whenever something breaks in the SVG, we have compile errors in a project, and we know right before it goes in production. So that was very important for us, and it's also very convenient so that we don't have to look it up, type it into a constants file, and then use it. So it's all one automated step.
So you're defining this by hand?
Hmm?
You're defining this by hand?
No, not anymore.
Okay.
That's a good part. So we
built the first time you run the...
Yeah. So, and we define it in the editor. In Illustrator or in Affinity Designer, you define them. The IDs are just the same that you give them as the group names. Whenever you have a group and you name it something in Illustrator or in Affinity Designer, this is what's then used as the ID. So we have an SVG with all the IDs, and we run over it in our pipeline, and this then generates this file for us. And if anything changes, the file changes, and all the definitions change, and thus it doesn't compile anymore. This also allows us to introduce more stuff, so we can add also classes to things, we can add whatever attributes we want to. So we can really use the graphics editors to annotate the SVG output. So we can say, okay, this is a button. Everything that has button on it will then automatically get a certain class or is treated in a certain way, and so on. So this really allows us to, and the important thing is to do everything in the editor and not hard-coded somewhere. Another thing that we did is also with the CSS files, because many times we add classes, we remove classes, we toggle stuff, and so on. So we also run over our CSS files, extract all the classes, and so on, to make sure that we don't mistype something. We don't add some mistyped class and nothing happens, and we don't find out until at the very end when somebody plays the game. But we always try to make sure that we find out at compile time and not during runtime. Additionally, then we also do it kind of with other assets. So usually it's one large SVG file, but then we might have additional assets. We might have audio files, additional images, and so on. And to make sure that these don't have typos in it, and somebody deletes it, and the code depends on it. If you delete it, then this just vanishes and your code doesn't compile anymore. Yeah, so that's pretty much it in a nutshell. So the main goal for us is to make sure things break at compile time, and this is kind of where we try to invest our time to. And this really allowed us to, having this pipeline, really allows us to kind of very rapidly create those small HTML5 games, interactive illustrations, because with SVG, there's so many things that you can quite easily do. We also started out doing animations. There's an animation pipeline that uses Adobe After Effects, and then you can export those animations to JSON. And then I guess it's BodyMove, and it's a Airbnb library that you can then use to animate things. So this is also something that we have integrated and something that we want to do more of in the future. Yeah, that's pretty much it. So thank you very much. Time's over. Looking forward to your questions.